This part 3 of chapter 2 is about the periodic table. It's kind of a short video, just 6 slides involved here. And I want to show you different types of presentations of the periodic table, a little bit of information too. So before I show you the different pictures of the periodic table, tables, please note that there are different parts of the table. One table I'm going to show you will show you the differences between metals, nonmetals, and metalloids, which are also called semi-metals. So the periodic table is just you can think of it in terms of 3 parts. The metals are on the left-hand side, and the nonmetals are on the right-hand side, and the metalloids are kind of that in-between section there. Then we're going to pay some attention to how the elements are presented in rows and in columns. The rows are called periods. The columns are called groups. There's 18 groups or columns. And I'm going to show you how you can talk about them in terms of the numbering 1 through 18 or the old-fashioned numbering with Roman numerals, kind of a historical way it was presented years ago. Nowadays we use 1 through 18. And then there's sections in the table for lanthanide and actinide elements. Then we want to look at the different groups. There's the alkali metals, the alkaline earth metals, halogens or halogens, noble gases. I'll show you where the radioactive elements are as well. So, all right. Then the first slide here is just one. It's a one that's current, so it has a total of 118 elements. If you just look online, you'll find lots of older versions of the tables where these elements in here hadn't been discovered yet, so they just had blanks or they had some kind of generic name, and now they've all been discovered and named. So anyway, I gave you this slide because it's got the names on it, so you can see Mn is manganese, for example. Iron is Fe. And then this one's kind of cool because it shows you, let's see, what language the name was derived from. And then what else is it here? It's got the name source. So it's a mineral, named after a mineral or some astronomical body, mythology, person, place, properties, and so on. And let's see, mercury, for example. Here's mercury. It's got the name of the element, and then it tells you that Mercury is one of the planets, right? The astronomical body. And here's osmium, and gray is the property. So it's based on smell. And let's see, what language would that be? I'm not really sure. Oh, green, I guess. Yeah, Greek. So Greek would be that. Anyway, this is kind of a fun one to look at. And this one here and show you what's going to happen in the next slide. So there's 118 elements, and we have this kind of blank space in here. Basically, if you pull this periodic table apart, it's possible then to fit all of these elements in this region right here. So the next one let me back up, of the table is where the lanthanides and the actinides that were below in the last slide are now in their proper place. And you can see the numbering 57, 58, 59. The section in light pink here, this is the lanthanide section, so it starts with lanthanum. This darker pink here, these are the actinide compound or elements, and they start with the element actinium. All right, the next one is just a simple table that just shows the 3 parts of the table. The nonmetals are going to be in green in this region. Hydrogen can be a nonmetal, or it can behave like a metal under certain situations, but oftentimes it's thought of as a nonmetal. And then the metals are the blue. These are the lanthanides and the actinides. Those are metals as well. And then the metalloids are right down here. Okay, so this separate the metals from the nonmetals. So let me pull up a blank slide here, and we can make some notes about metals. So metals, what are the properties? You think of aluminum as a metal, for example, or as gold as a metal. You could say there's luster, they're shiny, malleability, which means that you can pound them into very thin layers. Ductile or ductility means that you can pull them into wires. Metals conduct, so they have conductivity, so they conduct heat or electricity. And they can be reactive, and they're hard, right? So they can be reactive, not always, but oops, fix up. Sometimes they're inert. And then they're hard in general, hardness. Okay, nonmetals on the other hand, none of the above. So usually the metals are present just as, atoms that are lined up in a three-dimensional array. Nonmetals, on the other hand, appear as compounds. So you can have a compound like carbon monoxide or carbon dioxide. You can have nonmetals that will form compounds, I guess you could say. I mean, you'd say P4 is an element, but I mean, it's 4 atoms that are linked together. So you get that. So you get more bonding associated with the nonmetals. You would say just kind of the opposite. There's no luster. They're not malleable. They're not ductile. They don't conduct. They don't conduct. They can be reactive. They can be inert. And hardness is not really an issue. They can be solids, liquids, or gases. An example in the halogen table, group 17 or 7A. Solid would be I2, liquid would be Br2, and a gas would be Cl2. So you can have the 3 different phases possible for nonmetals. Also, you can see that many of them exist as diatomic molecules, not all of them. So you can have H2, Br2, Cl2, I2, N2, O2. Then you have P4, S8. Sulfur has a ring of 8 atoms bonded together. So you see quite a bit of the diatomic though, which is the 2 right here like that. And they have different chemical and physical properties. All right, then you have the metalloids. Oops. Those are the ones in between. They are boron, silicon, germanium, arsenic, antimony, and tellurium. Sometimes you see polonium, and sometimes you see tellurium. I'll just put X's through those because sometimes you see them, sometimes you don't. The table that I just showed you had polonium in there, and then tellurium was not, and then others it switches, and some of them have them both, and some of them have neither one. So they form that staircase called the staircase down the periodic table. In general, the metalloids are solids and at room temperature, and they look like metals. And then the trick with the metalloid is you do something to it and it transforms. So it starts out acting like a non-metal. You do something to it, like shining light on it, or maybe put it in the presence of an electric field, and then suddenly it starts to behave like a metal. So you could say it goes from non-metal behavior to metallic behavior, meaning that it's a conductor, which is a very desirable property. It conductors heat and electricity, and so you do something to it. You shine light on it, for example. So germanium is an example where you shine light on it and it starts to conduct electricity. So it can be used as a photoelectric detector. So light shines on it, and then electrons are emitted by germanium, and then that current can be detected, and it's a measurement of, the light that started the process. Then you have silicon here. So silicon, that is has non-metal behavior, and then you put it in the presence of a magnetic field, and it starts to conduct. So that's what happens with our computer chips. And some of the other ones have similar properties, so very interesting. Each one is different though. Arsenic is used as a semiconductor, and that one right there, arsenic. So those three anyway. And antimony, I've seen that as well, used as photoresistant materials. So you can read up on some details on that. Okay. All right. Now we can move on to the next periodic table here. And this one has all 118 elements again. I went through and updated my slides so that I could give you the proper symbols and names for the newly discovered elements. But I want to show you this one because there's two types of numbering. First of all, you have the periods. 1, 2, 3, 4, 5, 6, 7. So this is barium is in period 6, for example. And the periods are going to be very important. They're related to where the electrons in the outer part of the element reside with regard to the shell model. So these elements in period 6 will have electrons in that 6th shell around the nucleus. So we'll talk about that when we get to chapter 7. And then, or the chapter on quantum mechanics. Also the groups. So the groups, the old numbering is the A and B. This is what I wanted to show you here. So 1A, 2A, 3A, 4A, 5A, 6, 7, and 8A. Sometimes you see a 0 there. And then the B's are, each one is different here. That's interesting. Oh, I'm sorry, here it is. So 1B, 2B, 3, 4, 5, 6, 7, and 8 is this entire thing. So you have A is called the representative elements. Let me write that down. So A are the representative elements, and B are the transition elements. And most of you know the transition elements, but you don't necessarily call the other ones representative elements. So they have completely different properties, and we're going to study those, especially in the next section when we get to nomenclature. You'll know all about the transition elements. But so the transition elements are right here. Those are the B's. And the other thing I wanted to show you here was that's the old notation. Nowadays we just have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way to 18 like that. And then later when we talk about electrons in the valence shell, I'll call on you to know that 4A or 4 in the 14 tells you that there are 4 electrons in the valence shell, 5 and 5. If you know these numbers, you know that there are 5 electrons in the valence shell, and 6 and 7 like that. So we'll look at that. I'll come back. I'll remind you of that later. All right, and then finally, this slide shows you, this is an older one. I could not find a newer one that goes all the way out to 118, but I love the color coding on this one. And I created this whole part of this slide right here. So this particular color is associated with the alkali metals. So group 1A or group 1 are the alkali metals. This next one, these are the alkaline earth metals. These are the transition metals. And then you have, and this, I haven't mentioned this yet, but so the purple here, those are the metalloids. So boron, silicon, germanium, arsenic, antimony, tellurium, and polonium, sometimes acetine. So I was just talking about those. But then under the staircase is this set right here, and they're called the post-transition metals. So they have properties like the regular transition metals, and you'll see what I mean by that. The metals can have more than one charge when they're in the ionic form. All right, to the right, all of these are nonmetals. These don't have any particular name, so we'll just call them nonmetals, but these nonmetals have the name halogen or halogen, and these nonmetals have the name noble gas, rare gas, or inert gas. And I guess I cut out there, but it just says that they're nonmetals as well. All right, then down below, these are the lanthanides and the actinides. As you can see, they fit right in here. So 57, lanthanum is the beginning of the lanthanide series. 89, actinium is the beginning of the actinide series. So is lanthanum a lanthanide? Yes, it is. Is actinium an actinide? Yes, it is. Just the way the rest of them are. All right, so that concludes the section on the periodic table.